Welcome. So if we take a look here, it's Thursday, January 21st. We did not need these organic notes, period 5-6. Basically, I went over some stuff. Um, like I said, I'm basically like holding on by a thread here. I still had to prepare a little bit for IB today. So if you have questions, please ask me. Keep in mind, by doing that until Monday, that means that tomorrow, if you the people in here, they'll have time to review. And if you want to review with them, by all means. Today, I'm going to go over any questions from the old review that you did. And then I think I actually got this class, the second bonding review up. So if you did not do this yet, that's a good review. It has the AZT and stuff like that on it. Without further ado, let's do that. Let me make sure that this is set up correctly while I have it here. Oh, I already said it. Don't be gross. So we got that. You have 57 minutes to complete it. Lock questions after answering. Oh, I wonder if I should do that since, yeah, one question. Does that suck when I don't know what it means really.
It means you have to like press next every time so you don't scroll down. So you can't like answer all the questions at once and see all of them.
No, that's the way I have it. It says one question at a time. That's good. But what a lock questions, you won't be able to go back and answer them.
You can't go back and change your answer.
Yeah. Dun dun dun. All right. So it says available from January 22nd to January 25th. Do those dates make sense? Today's the 21st. Friday, Saturday, Sunday, Monday. So we're good. All right, cool. Let's set up. Don't be gross. It's that easy. Cool. So any questions on page 24 and 25? You guys see that okay? It looks like garbage, doesn't it? Let's make better. Oh. Let's get rid of this. You don't need that. Shove it down here in the corner. What do you think? The answers to these are available, right? I'm just going to check. Okay, cool. 27 on page 25. Yep. So, oh, this is a good question because now I've got to answer like 3 questions to get this. This is good planning. So we take a look. Why am I only showing like half? There we go. So what type of hybridization occurs? In order to have the hybridization, I myself need the Lewis structure. So if we take a look, we have C in the middle, BR, BR, H, H, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. 4 plus 2 is 6, plus 14 is 20. So we're good. What type of hybridization occurs to the C on 26A? So, oh, okay. No worries. No. So if we wanted the hybridization that occurs on C, on the carbon in 26A, then we need to count the bonded atoms and the electron locations. Basically, anything that's not a double bond counts. So we start to count with S, P1, P2, P3. So that's sp3. That's tetrahedral arrangement. And the actual shape is also tetrahedral. Yeah. Let's try SeF4. SE. Well, it looks exactly the same. 2, 4, 6, 8, 10, 12, 14, 16, 18, 30, 30, 32. Well, let's check to see if we have 32. SE gets 6. 4 times 7 is 28, plus 6 is 34. That means we have a lone pair on the SE. What does that mean?
Isn't the arrangement like trigonal bipyramidal?
That's great. I'm glad you said that. Isn't the arrangement trigonal bipyramidal? It is. The arrangement is trigonal bipyramidal. 4 is tetrahedral. 5 is trigonal bipyramidal. 4 is sp3. 5 is what?
DSP3,
Switch it, flip it.
SP3D,
There we go. S, P1, P2, P3, D. Right? So the SC here is SP3D1. And blah, blah, blah. With this one, it's going to show resonance. Oh, I didn't even see that, but yeah, right? La, 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 la. 4 plus 18 plus 2. What is it? 20, 26?
24.
24. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. We've got 2 extra. So we're going to need a double bond somewhere. The fact that we can put a double bond in different places tells us that it does show resonance. Let me ask you this. Are you comfortable with the formal charge of the carbon there? What is the formal charge of the carbon there?
0,
0. What's the formal charge of this oxygen?
0,
0. This one?
-1.
Is he answering too fast? Should we slow him down? Put yourself on mute for a bit. And this one?
That's also -1.
Who is this?
The Brody.
Brody, good. That is also -1. SC right here, Brody.
Wow, 1 second. How many valence electrons does SE have? I don't know that off the top of my head.
Okay, it's in the oxygen family, so it has 6.
So it would be 0.
Very good. I thought you were going to get confused because of this line, but you nailed it, sir. All right, good. Put yourself on mute. Somebody else. How about this carbon, Rajha? 0 is correct. What is the carbon right here's hybridization? SP2 is correct. Don't get confused and count a double bond as 2 of them. S, P1, P2. Basically, SP2, all the SP stuff hybrid. Basically, you're looking for high electron density locations. High electron density locations. I don't even know, but that's what you're looking for when you're doing that. Which structure would have a pi bond?
Would it be Cr3 2-?
Yes. If you recall, a single bond between something is a sigma bond. A double bond has a sigma and a pi bond, and a triple bond has a sigma and 2 pi bonds. And it's the same for the rest of it. Cool. Brody told me that I messed this up yesterday on the key, so you're gonna want to check that. He says I wrote 107.
Hey, Mr. Jackson, I have a question.
Yeah.
Would you say something about high electron density? Could you repeat that? I couldn't hear you.
Yeah. So if we're looking here, this is that new sheet. I don't know if you printed it out, but when we're looking at regions of high electron density, basically that's what hybridization shows us. If it has 2 high electron density locations, we'd say S and P. If it has 3, SP2, 4, SP3, 5, SP3D, 6, SP3D2. And keep in mind that let's even imagine that these 2 things right here are double bonds. It still only has 2 areas of high electron density, right?
Yeah.
if this right here, this is a bond, this is a bond, this is a bond, and this is a lone pair of electrons, there are still 4. We count that lone pair of electrons, but we don't count double bonds when we do this. So there's a lot of ways to do this sp3d stuff. I basically just count high electron density locations. And in my mind, I don't count double bonds or triple bonds, except for one. Some people say, I'm going to just memorize that 4 regions is sp3, 3 regions is sp2. Some people say, oh, well, I'm going to memorize that if it's tetrahedral in arrangement, then it's sp3, blah, 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 right? That's the cool thing about the chemistry, because there's so many different ways to get from point A to point B.
Thank you.
You're welcome. So let's take a look then at this guy, and I'll do one of each of these unless you guys have more questions, then obviously I'll answer them. So let's take a look here. I want to try to find one that's kind of cool. Oh, Brody corrected me on this too. Make sure you don't do this one twice. G and I are the same thing. This is one of the pages from the second review guide. Yep. And it does not have page numbers, unfortunately. Which one's cool to do, Brody?
Sorry, what?
Which one of these is cool? Which one's a little bit harder than the others? Or did I already do all the hard ones? Is this one hard?
Oh, I feel like they're all the same. I guess F was a little confusing.
All right, let's do which one?
I guess F because boron, doesn't fulfill the octet rule, but I feel like they were all pretty straightforward.
Does Cl fulfill the octet rule here, or is it weird?
I had it fill its octet rule.
All right, let me try it real quick. You're probably a lot quicker with math than me. So if we do this, I got 28, right? Here's 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28. So what you got?
Yeah.
Yeah, cool. So actually, it does screw up the octet rule a little bit. So if we take a look, identify the hybrid orbital type. So we have 1, 2, 3, 4, 5 areas of electron density, or high electron density. So S, P1, P2, P3, D1. S, P3, D1 hybridization. What is the electron arrangement for this? You guys can unmute yourself now. Oh. The shape is T-shape. What's the electron arrangement? Very good. It said in class that it is trigonal bipyramidal because it has 3 bonded atoms and 2 unshared pairs for a total of 5 HEDs, or high electron density locations. The actual shape is T-shape. If you can look at it and it's like a weird T going this way and that way, then that's what that is. The one that Brody said, C in the middle, CL, CL, CL. We end up with 3 plus 21 is 24. 2, 4, 6, 8, 10, 12, 14, 15, 18, 20, 22, 24. How many areas of high electron density? SP2, right? And that is what arrangement?
Trigonal planar.
Trigonal planar is correct. And what shape?
Trigonal planar.
Good. Easy enough. Cool. AZT. This is, you've seen the Dallas Buyers Club. This is one of those drugs that you're talking about in the Dallas Buyers Club. HIV drug that helped a lot of people out in the 80s and 90s. It looks like I've already ruined this one and completed most of the things, but by looking at something like this, you need to be able to identify hybridization, angles, and stuff like that. This is a big old molecule. This is what we're getting into when we talk about organic chemistry. Basically, these big carbon, nitrogen, oxygen things. So let's start it off with this guy right here. Can anybody give me his hybridization?
SP3,
sp3, what's the shape?
tetrahedral,
Tetrahedral. 4 bonds, 0 unshared pairs right there, right? How many sigma bonds does it have?
4 sigma bonds,
And how many pi bonds?
0.
Good. So that's the kind of thing you should be able to sit here and go, ba-da, ba-da, da-da-da-da. You guys going on a walk? People still zooming. That's Mr. Groff. He is the art space science teacher, and he also teaches 8. What do you guys talk about today? Beef? Good talk. So if we take a look here, who wants to play this environmental, AP environment? Yep. He teaches 8, like I was calling the student stuff. Somebody help me out. Hybridization.
SP2,
Is he right? He is right. How many pi bonds? 1. How many?
1.
3. Oh, they're beating you in class now. They're trying to show off for the AP environmental teacher. This guy right here, hybridization.
SP2,
sp2. Sigma bonds.
1. No, 3 sigma bonds.
Yep, 3. And how many pi bonds?
1.
How about this guy? This oxygen. Is it sp?
Is it SP2 since the 2 lone pairs on it?
Yes. This has 2 lone pairs that aren't written that you have to be able to sit there and go, oh, no, it probably has 2 lone pairs. It should. That means it is sp2. How many pi bonds?
1.
How many sigma bonds?
1.
How many high electron density locations?
3.
What is the arrangement?
Trigonoplanar,
Trigonoplanar, in a sense. 1, 2, 3, right? How about the arrangement of this C?
trigonoplanar,
This C?
trigonoplanar,
This C?
trigonoplanar,
This C?
trigonoplanar.
This N?
Wouldn't it be tetrahedral?
Would, because there is a lone pair on there. So what is its hybridization?
SP3,
All right, put yourself on mute. How about this guy right here? Yeah, good question. Everything, go. Hybridization. sp3, because it does have a hidden lone pair. The shape, the arrangement would be tetrahedral. That's okay. The shape of it would be trigonal pyramid, right? And there's just those little things. And I tried to, when I wrote the test, I tried not to make it too bit difficult. All right, how about this one? Hybridization. Call on some people. I got an email once from my mom. My daughter doesn't like it when you call on her because a lot of times she's not listening to you. Like, makes her nervous. So if you're not listening to me, start listening. Gabe. Let's do it. Hybridization.
SP3.
Very good. Just give me the shape. Remember how we do that? We basically take just that and look at that. So two bonds.
Are you still asking me?
Yeah, sure.
Tetrahedral?
So the arrangement is tetrahedral, 1, 2, 3, 4, but the actual shape of what this looks like.
Hang on, let me get the sheet out. Tetrahedral as well?
Nope. There's only two bonds and two unshared pairs.
Angular?
Angular or bent. Good. All right. Let's open this up to everybody. How many sigma bonds for the oxygen?
2,
2. How many pi bonds?
0,
0. This N right here, how many sigma bonds?
2,
2. How many pi bonds?
2,
2. What is the hybridization?
SP.
Oh, you guys didn't fall for it. SP. So what is wrong with this then? Come on, Brody, point out something wrong. You like pointing out the stuff I do wrong. What's wrong with this?
It's a linear shape, but it's got a bent to it.
You got me. You got me good. It should look like this, shouldn't it? If that's SP hybridization, there is no, remember this is called the Vesper theory, valence shell electron pair repulsion. There's no electrons on top or bottom here to cause this to bend. It's two double bonds. It's not going to bend. It should come off straight. Good job, brother.
Wait, Mr. Jack.
Yeah.
For D on that thing, I got 38 total sigma bonds, not 33.
Are you saying that my sheet's wrong on the answers?
No, I was just wondering, like, I don't know if I mean, I'm pretty sure I counted right, but I'm not sure.
You're saying that the answer sheet says 33?
Answer sheet says 33.
Oh, let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 30, 31, 32, 33. Which ones didn't I count?
Well, I mean, I don't know. Maybe the double bonds you didn't count. I mean, I'm not sure.
Everybody count them.
I counted. I got 38.
I think I got 33 again. Everybody's getting 33 here. 34, 35, 36, 37, 38. Are you counting the double bonds as 2?
I'm pretty sure I'm counting it as 1. Maybe it's just, maybe I'm counting it as 2. I'll see.
So that's the one thing I think, or else we can't count. But those are the pi bonds. So how many pi bonds would there be?
5.
All right, good. So as long as we can all agree, nobody has to count these anymore. As long as we can all agree that we understand that the single lines would be 1 sigma and the double lines would be 1 sigma and 1 pi, the actual number there, I could care less about. Does that make sense?
Yeah.
Cool. Cool. All right, Brody, out of 1 through 8, are any of these difficult?
No, they're all particularly the same difficulty.
All right, so should I do one or not?
I mean, you can do it for fun.
All right, for fun, which one should I do? Anybody? Oh my gosh, we will roll a d8. Oh, number one. Easy enough. Was that enough of a roll for you? Yeah, that was. All right, let's do it then. Number one. Who's in the center? AS, why is it in the center? Because it's what? Because it's unique. That's one reason why something can be in the center. What's another reason why something can be in the center? Least electronegativity. That's not hydrogen. Good. And it's not the case here, but what's another reason why something could be in the center? Nope. Anybody?
Because it forms more bonds.
Because it forms more bonds. Huh, great. Hydrogen's never going to be in the center. If you have it between oxygen and nitrogen, it's going to be nitrogen. If you have it between nitrogen and carbon, it's going to be carbon. So there we have that. What is the arrangement? 1, 2, 3, 4, 5. Good. What is the shape?
Trigonal bipyramidal.
Good. It's all bonded out, isn't it? What would be the shape if we had a lone pair instead of one of the atoms?
Seesaw.
Seesaw. On the test, I borrowed some questions from some other teachers, and they wrote seesaw. I may not have caught it. That is not correct. It is seesaw, right? You don't cut the ocean with it. You see, and then you saw, then you see, and then you saw, right? Or teeter-totter, but they don't have teeter-totter. Nobody uses teeter-totter. Bond angles for a seesaw.
Isn't it 90, 120, 80? Or 180, 20?
Here's a 90. Here's a 120. You say 120? Here's a one.
Yeah, 120 and 90 and 180.
Here's a 180 across the top, right? Polar or non-polar? Are these bonds polar? Are the bonds polar? What is the electronegativity difference in the bonds?
They're polar.
Right, we have 4.0 minus 2.4. They're polar. So if we take a look here, there is one lone pair at the top. So each of these fluorines is going to be pulling. This one's going to be pulling that way. This one's going to be pulling this way. That one's going to be pulling this way. And that one's going to be pulling this way. So while these two will cancel each other out, this one and this one are both pulling into the table. There is nothing pulling out of the table. So that means that there is not an equal pull in every direction. That means that if the bonds are polar and there's not an equal pull in every direction, the molecule is polar. Last but not least, somebody giving a hybridization. sp3d1.
Wait, Mr. Jackson,
Oh, wait.
on your answer key, it says that you put it as non-polar.
Yeah, you know why? Because you're
Forgot one of the.
talking me into that being, or me talking myself into that being seesaw. The shape for this is trigonal bipyramidal, right? Let's change it.
Yeah.
Let's do this. Boom.
Wait, so if it was ASF5, then it would be non-polar?
Yep. If it was-
Okay.
I think I just wanted to talk about seesaw for some reason. So in my mind, I made that seesaw. You got it. The key is still correct on there. I just got talking about seesaws for some reason. Yep. Whenever you said, where's the lone pair? I was like, wait, I'm doing the wrong one. If we take one more of this away, where will we take it from? We take one more atom away. What will the shape be?
Oh, T-shape.
T-shape. So if we take one away, we're actually taking away from the seesaw aspect to get that T-shaped. So the 180 still exists, the 90 does, it's the 120 that's gone. These two lone pairs here are what keeps that one in check, going that way. If the central atom, if these were all polar bonds, would the molecule be polar? With lone pairs there and there? Yeah, you have something pulling this way, but you don't have anything pulling back this way. Now, as was pulled before, if this were ASF5, it would be trigonal pyramidal arrangement, trigonal pyramidal shape. And remember what made this polar when it was a seesaw? Now with that extra atom there, we have a 120, 120, 120 pull in every direction, canceling each other out. We have a 180 pull this way and a 180 pull this way, canceling each other out. So in the case of ASF5, this would be nonpolar because everything does cancel out. That's all I got, but I'll answer questions if you've got them. Have a great day and see you Monday, unless you join us for tomorrow's thing. You guys playing hooky tomorrow? Yes. Get out of here unless you have questions. Thanks for dropping by, though. Probably. Which period? Yeah. Which period? Oh gosh, I gotta clean this place up. Which period? Which day do we what? We'll be starting on Tuesday. Oh, I'm gonna end this so that I can record it or whatever. Brody, are you good?
I have a few questions actually.
All right, go for it.
All right, for number 2, it has a linear shape, but there's quite a few lone pairs on that middle atom.
How many lone
So there is 3.
So that's exactly
So
what you're taking. If you take it one more time, so if we take this one more time, we take off one of the trigonal parts, another trigonal part, and another trigonal part. That's how we get that linear. Lone pair, lone pair, lone pair.
So like the off balance of valence electrons in that central atom doesn't push anything a weird way.
No, it pushes that straight out that way and that straight out that way, which keeps it at 180.
So that's why it'd be nonpolar.
That's why it would be nonpolar, because they're both pulling out opposite of each other. Yep.
And then for number 3, I also have about polar, nonpolar. I got it as nonpolar because I thought that lone pair on the TE would push everything a weird way.
Okay, so I think what you're doing is you're saying that I think it might be opposite. If it has a lone pair here, it's more likely to be polar. So what is that? Is this the shape of it?
Yeah.
That's seesaw, right?
Yeah.
So that means that there's a lone pair here, which means that there's nothing pulling in that direction. There is something pulling here and pulling here, but remember, polarity is based off of the pull in the direction towards the more electronegative. So that lone pair right there prevents something from pulling in the direction of that lone pair, which means that it's got a overall pull in that direction with nothing pulling back in that direction. So that's what the polar is. It's the pull in one direction.
Okay, and then for the next one, actually, it's got the 5 to the, it's got there's 5 different bonds between the bromine and the fluorine, But so does that would that but bromine also has an extra electron. I mean, an extra like lone pair. Would that make it
Square pyramidal.
polar?
Square pyramidal.
Yeah.
Yeah. So it's square pyramidal. Again, there's something on top pulling those electrons toward that fluorine. There's not anything where that bromine is. I'm sorry, there isn't anything where that lone pair is. So here's our square. Let me go ahead and put it with a like one. So here's our square, right?
Mm-hmm.
And our, why did, here. Here one. Got it. So the square pyramidal. There's nothing pulling where that lone pair electron is. So there's nothing pulling that way, but there is something pulling that way up top.
Oh, yeah, that makes sense. So does that mean anything with like a lone pair on the like the central atom cannot be polar? I mean, sorry, non-polar.
It can be with a lone pair if the bonds are not polar. If the bonds are not polar, then you don't even have to look at the canceling out, right?
Yeah, I guess it doesn't make sense.
Anything else, Ben?
No, that's all I had. Thank you.
Do you need me to be in office hours today or anything?
Probably not today. I think I can get the rest of it.
All right, cool. My
Thank
office hours are back to Tuesday and Thursday right after school till 3:15. I'm gonna have to post that at some point on the front page, but I just wanted to ask you if you needed them today.
Okay, yeah, I should be all good. Thank you.
Yep. Have a great day. Yes. Because carbon is what allows for the big complex structures. Like all those like that you see back there, the things in the middle holding everything together are the carbons. Because it can have those 4 bonds. We are carbon-based life forms, right? But we're 80% water, right? Yeah. But our carbohydrates, our proteins, our DNA, the main atom that actually makes up all that junk is the carbon. The water is just so that your body can transport nutrients and garbage throughout it, right? Because you're a big complex thing. Yeah, it's one of the bases for life, yeah. That Under Armour shirt looks like a Stranger's Thing logo. Is that on purpose? Yeah. Just showed up in the drawer one day, huh? I got one like that. I got a shirt and I asked my buddy, like, is this yours? And he's like, no. I have no clue of where it came from. All right. I want to be done today. That would have been bad. My goal is to go home and grade or dump my IB kit off and have them go do something else and grade those, what are they called? The laboratories. So we'll have them, and that way I can identify if anybody is garbage is and pull that area or something like that. But hopefully if you have like 3 people in your group or 2 people in your group, you're able to get it. Let's see. We cropped out some of them on here. If they're in parentheses, yeah, don't worry about them in parentheses except for the long one. of my IB students, he skips my AP class in the morning, then watches the video. And he expects me to teach all day long and then teach kids 10 right? That's like God. You know, star, you know, star. So you look at my kids. What's that? Yeah, right? He has jacked up his schedule so bad. Oh. I don't even know. What is he in the activities? Like sports and stuff or band? It just seems like he's staying up until way too late at night. Yeah. We're kind of on hold right now with that. I'm hoping after we get out of organic, as you can see, like the organic things up there, usually we would have you make those and stuff like that. This year I'm thinking about doing the poster instead and just making it like, what do you call those things, brochures?
At this time, the
But
following
just maybe
all
make
would
it like a one-page website thing,
upper
or a picture.
P-H-L-N and lower A, B, D, J, K, M, and J, M.
In the past, we've made acetylsalicylic acid, which is aspirin. Like we made aspirin in the laboratory. We made wintergreen, but I'm not ready to sit there and put everybody back there yet. I mean, everybody in here said that they never tested positive, right? I mean, we're all susceptible at this point. And, you know, one of you get it, and then the other person gets it in the laboratory. I got to deal with that the rest of my life. So, I'm hoping by the time I get done with that, maybe today, did you guys hear like the distribution plan for the vaccine is almost non-existent? It's all dependent on the state. Like, there's not a, yeah, right? That's what we thought. My dad's like, no, I don't get that in my body. I'm like, whatever, dad. But we're dealing with that. Yeah. There are some cool labs later on, and there's one lab that's like the hardest thing in the world. The lab that told you to do it on. All you do is make salt water and then dry it out, but it's hard because you actually have to think about all the things. I'm hoping that we'll get that done. That can be an individual thing. And with this group, 2, 4, 6, 7, one of you guys is going to stay here probably, right? Somebody's
J,
going back to
K,
school.
M, and lower E, H, K.
Who's it going to be?
We shall see.
Is it somebody bored today, or they thought today sucked, or you guys actually happy? Okay, maybe not. Have a great day, guys. Stay safe and be good. That's what I'm saying. I thought the day was over. Yeah, every time.